guys, welcome back to the last session of Chapter 5. Now, in this session, we are going to talk about bond convexity. Now, this refers to how curvy between the relationship of price and yield. We have seen that the price and yield being a curve rather than a straight line, which is actually not as shown by the modified duration, because the modified duration assumes a linear relationship between a small change in yield and the percentage change in price. Because we know that the actual price yield is a curve rather than a straight function, we know that there is going to be some type of error. Now, let's look at the price yield function for two alternative bonds. Now, this one is definitely showing a convex function. Now, this is the price yield function for a bond that has 0% of coupon, and it is a long maturity bond. It has 30 years of bond life. Now, in comparison, this is still a curve, but it is very similar to a straight line, or it is showing a linear function between price and yield. And this is the price yield curve for a 12% bond and a short-term bond, which is only 3 years. We know that based on our knowledge, we know that these two bonds actually have very different level of interest rate sensitivity. Now, for this bond, which has lower coupon and longer maturity, it definitely has higher level of interest rate sensitivity compared to this bond, which has high level of coupon and low term of maturity. So, we can see that these two functions also have different level of convexity. Now, convexity refers to how curvy that curve is. We can refer one conclusion from these two lines, that is, if a bond is comparably have a rather flat, not that curvy line compared to the other bond, it must have a lower level of interest rate sensitivity. So the convexity of the price yield curve actually is a direct measurement of the interest rate sensitivity. But it is different from the duration because it is more of a reality representation, while the modified duration is to give the coefficient. It is a quantified measurement, which some estimation errors is allowed for. We can notice one thing, though, that is the convexity is, let's say, it shows how much a bond's price yield curve deviates from the linear approximation of that curve. Now, what is the linear approximation? The linear approximation is actually the duration. It is the modified duration. See, this is the actual price yield curve, and this line is the estimation given by the modified duration, and we can see this modified duration more of a tangent line for the actual price yield curve, and these two actually deviate from each other. Now, this is where the convexity took place. Now, this is the convexity, and it is this is what actually happened in the reality. See that the determinants of the convexity, let's go back to this graph, is actually, it is related to coupon and maturity. Because coupon and maturity is the most basic characteristic of bond that determines this bond's interest rate sensitivity. And the convexity is in turn a reality representation for the extent of the price yield function. We need to notice that when there is a change in yield, see, this is a very small change, y1 to y star, y2 to y star. So this is a decrease and this is an increase. Now, this is an example of very small change in the price yield, which we can use the modified duration to estimate the change in price. However, if the change is, let me clear the board. Now, if the change is from y star to y4, now this is an example of a large change in yield. And we can see that if we simply follow the modified duration, it would expect the final price being here. However, based on the actual price yield function, the price actually lands here. So that means when there is a large increase in yield, the price drop tends to be overestimated by the modified duration compared to the price yield curve. Now, let's look at this change in another direction. If the change happens from y star to y3, there is an decrease in yield. Now, this is the price estimated by the modified duration. So that's the tangent line. And there is the price given by the price yield curve. And we can see that when there is a large decrease in yield, the final price given by the modified duration tends to be lower than the actual price appreciation. So that means it will cost our investment opportunity, because when there is a drop in the interest rate, we actually underestimate how large the price increase can be. When there is an increase in interest yield, we actually overestimate how far the price is gonna drop. So that's why this modified duration cannot be used when we are facing a very large change in yield. Now, we want the convexity investments because it actually shows a very interesting function. Because when the bonds yield increase, the rate at which the price of the bond declines becomes slower. And when the yields declines, the rate at which the price of the bond increase becomes faster. Now, the price of a high convexity bond increase at an increasing rate. Now, let's look at this line here. Let me clear the board for you. Now, we can tell that for this bond, it definitely have larger, let's say, extent of the convexity. Now, for the left upper side, we can see that this part has a much larger slope compared to this part. Now, when the yields continues to grow, the curve itself becomes flat out, or the convexity actually becomes smaller and smaller because it is more like a linear function here. And on the opposite way, when there is a decrease, in the bond yield, there will be an increase in the bond price. And we can see that from this direction, it's actually become larger and larger. So that's why we say when there is a decrease in the bond yield, the increase in bond price becomes faster when there is the presence of convexity for the price yield function. Now, that's why we say convexity is desirable. And for two bonds, they can have the same level of duration, yet they might have different level of convexity. So, if that's the case, the bond with greater convexity actually have better price performance. Why? Let's see this function. Let's assume that this is, my drawing is not perfect. Let's just assume that this is the price yield function for a bond that has the same level of duration with this bond, but with clearly larger content of convexity because it is more curved compared to this one, right? So that means when there is a decrease in yield, the price increase will be larger for this one. And when there is an increase in yield, the drop in the price will be smaller because this one is higher than this one, right? It meaning that the price of this bond will be higher than this bond. So that means the bond that have a larger convexity actually gives better performance, both when there is a decrease in yield or when there is an increase in yield. So it accelerates the way we enjoy the price increase in bond, and it also protects us from a drop in price when there is an increase in yield. So that's why the convexity is a very desirable feature of bond. And when we expect a change in interest rate, we need to look at both the duration and the convexity of the investments. And also, let's refer some of the convexity features. Well, the first one is there is an inverse relationship between coupon and convexity. Well, that's true. Just looking at this line, right? There is an inverse relationship. Lower coupon have price yield curve being more like a curve. And the term low term bond also have low level of convexity. So we say that there is a positive relationship between the maturity and convexity. And not showing by the graph, we can see that there is an inverse relationship between yield and convexity. Why is that? Now, we know that convexity is somehow a direct measurement of the interest rate sensitivity. And we also have other interest rate sensitivity measurements, such as the Macaulay duration and the modified duration. Now, in these two measurements of durations, we know that the yield is negatively related to those measurements because for the Macaulay duration, the yield appears in the numerator and it measures the present value of the cash flows. And we know it has a negative relationship with the present value of cash flows. So that means because of the presence of yield in numerator, it is actually negatively related to the value for the Macaulay duration. And we know that the modified duration is developed from the Macaulay duration. So that means there is also a negative relationship between the modified duration and the yield, let alone the yield in the denominator for the modified duration. So that's why the modified duration, with no doubt, have a negative relationship with the yield. So that means two measures of interest rate sensitivity having a negative relationship with the level of yields. So that's why the convexity, which is also another measurement for the interest rate sensitivity, also having a negative relationship with the yield itself. Now, these are the features of a bond's convexity that we need to keep in mind. And as finance people, we don't run away from the convexities because it actually represents better performance for bond during any direction of change in bond yield. Now, we wouldn't introduce the calculation of the convexity because I just want you to remember why there is the limitation for the estimation of the modified duration and what is the true relationship between the yield price function. Just remember that and keep that in mind that a convexity of a bond is rather desirable function or feature of that bond. Now, let's make a quick summary for the content that we have learned in Chapter 5. Now, the first thing is we know how to calculate the bond price. We know it is the present value of all the future cash flows discounted back to now. Now, the future cash flows includes both the periodic payments of coupon and the repayment of capital at the end of the maturity. Now, we know that the coupon is in the form of annuity, and the payment of principal is a lump sum one-time payments. And we also know about many types of yields: the nominal yield, the current yield, the promised yield to maturity, the realized yield to maturity. And we also know that the realized maturity, we need to calculate the future selling price, and if we want to realize the promised YTM, we need to first hold the bond to maturity, and second, reinvest our coupon payments at the rate of the current YTM. And we also learn how to measure the interest rate sensitivity by the use of Macaulay duration and the modified duration. And we use them to form a meaningful investment decision to allow us to explore the interest rate change. And as finance people, we don't run away from a change in interest rate. We use it to our advantage. And the modified duration actually shows a linear function between a very small change in yield and a change in percentage of the price. And we say that it is not the reality, it is only an approximation because of the presence of bond convexity. And convexity, again, is a desirable feature for bonds. All right, so that'll be the end for this chapter. Thank you for joining me.